So we're going to continue with that same situation that we were talking about on the previous page and write an equation for it like we did on the first page, but also now make a graph and a table of values that we can see. So let's go ahead and read again. Here's a situation you saw earlier. Diego bought some raisins and walnuts to make trail mix. Raisins cost $4 a pound and walnuts cost $8 a pound. Diego spent $15 on both ingredients. Write an equation to represent this constraint. Let x be the pounds of raisins and y be the pounds of walnuts. All right, we are using this word constraint again, and we talked about that earlier in the unit, but it may have been a while. So remember, a constraint is essentially a limit to the values in our problem. So we have to think about what is a reasonable value and what is a limit to a value. So raisins being $4 per pound, so that's a limit to the cost of the raisins, and walnuts being $8 a pound, that's a limit to the cost of the walnuts. And $15 total is spent, that's a limit as well. And when we think about our problem, positive values will also be kind of limits, because it wouldn't make sense to have negative values of raisins and walnuts for the number of pounds. So a constraint is a limit to the reasonable values. So let's go ahead and write that equation again. We already wrote the equation on the first page. However, what we're going to do now is use x and y as our variables. So recall, raisins cost $4 per pound, and now we're going to say x is going to represent pounds of raisins. And then we have walnuts cost $8 per pound, and we're going to say y is the pounds of walnuts. And then we're going to continue to remember that $15 is the total amount spent. All right, so if we're going to write the equation, $4 per pound of raisins, so 4x, plus $8 per pound of walnuts, so 8y, equals a total of $15 that we're going to spend. Use Desmos to graph the equation. Sketch or paste the graph below. All right, so let's head over to Desmos. Up in the top left, let's add in an equation. So 4x plus 8y equals 15. Now, when you see your graph, you might not have the same window that pops up here. So what you can do is take 2 fingers and kind of pinch in on your y-axis or pinch in on your x-axis, or adjust that window to make more sense. Now I'm going to zoom in, like I said earlier, kind of on the positive x values and the positive y values. So I think that makes the most sense in our problem, be focusing in on that. So I'm going to adjust the window. So I'm just essentially looking at that first quadrant that has positive x values and positive y values. We're going to go ahead then, once you have that figured out, it doesn't have to be exactly the same as mine, but just kind of get a good picture of your graph here. And then let's go ahead and do a screenshot of it. I like to crop this just a little bit here so it focuses in on our graph. We'll hit done. I'm going to save it to my photos. Go back to Notability, and then I can bring that in. You guys have done this before, but just reminding you, then it's easy to bring in from your photo library. Actually, not that one. This one right here is the one I want. Let's drop that in here. Fantastic. All right, fits kind of nicely too. All right, so now we've got the graph. We need to reference that. There we go. So remember, anything on the graph will work for a combination of walnuts and raisins. So there can be fractional amounts of pounds, but anything along here, any combination of pounds of walnuts and raisins will work. Remember, on our x-axis, we have raisins. Raisins are on our x-axis, and then walnuts are on our y-axis. This is pounds. So might be good just to label that. So pounds of raisins, pounds of walnuts, and then all these points that are on our line would be combinations of pounds of raisins and walnuts that would work. So let's get more specific and see if we can find some combinations that work. On the first page, recall, we found a combination that worked. This one right here, 2.25 and 0.75. In fact, let's look on our graph. 2.25, a little bit hard to see here. Let's see, I'm going 1, 2, 3, 4, 5. So it looks like it's broken into fifths. So that's about right here. 2.25 pounds of raisins, and let's see, does that match up with about 0.75 pounds? Yeah, so that's like about 0.75 over here, and about 2.25 here. So notice that matches up. Okay, so that was our combination on the first page. Complete the table with the amount of one ingredient Diego could have bought given the other. Explain or show your reasoning. So let's look at a couple others that actually also work here. I'm going to erase the ones that are on, that is randomly put there, and include some ones that we see here. So one combination that works is 0, 1.875. So notice that's that one right there, 0, 1.875. So that combination works. Let's look at another one here, 0.25, 1.75. So that is going to be, it's about 0.25 here. And if we follow that up, yeah, so that's going to be about right there. So that's 0.25 and 1.75. So that's a combination that works. So we have a number of combinations. Here's one on the bottom as well of our table. So 3, and that's this one right here. So that matches up. Yes, that's about 0.375. So lots of fractional ones here, which of course you can have if you are going to the grocery store and you're getting pounds of candy or nuts or anything from those big bins and you're weighing out the pounds. They will break it down into fractions of pounds. All right, what about some of these other ones though? Actually, there was another one, 1.25, 1.25, but I think you got the idea. What about some of the other ones that we need to solve for? So let's do this one. I'm going to say this one. Let's find a color here. So this one over here. All right, now on this one, we're saying the walnuts are 1.375 pounds, but we don't know the pounds of raisins. So let's think back to our equation here. So that means we don't know the x, but we do know the y. So if we think about our equation up here, 4x plus 8y equals 15, I'm going to put in 1.375 for our y value. And now go ahead and work that through, and we're going to solve for the pounds of raisins. Now we could estimate that on our graph. 1.375 to be somewhere right in here. So you're going to be able to come up with a pretty good estimate right over here. It's like 1.375 is going to be about right there. So you can estimate it's going to be right around 1 or close to 1. Let's just see what we get here. So 4x plus 8 times 1.375. Use your calculator if you need to. Oh, looks like my calculator is updating. All right, I'm going to use a different calculator. 8 times 1.375 is 11 equals 15. All right, so now we're going to solve for x. So we're going to work backwards. Two-step equation at this point. So let's undo addition by subtracting 11 from both sides. Bring down what's left. That's 4x equals 4. And then 4 times x will undo by dividing both sides by 4. I get x is equal to 1. So actually, yeah, it did turn out to be 1 then. So 1, 1.375. So if I look here at 1 for my raisins and follow that up to the graph, yeah, so that point right there where it matches up with the graph is 1.375. So that works. That's a combination that works for pounds of raisins and pounds of walnuts. Okay. Let's look at the other one. So over here, now once again, when I say here, let's look at this one right here. So this time, I know the pounds of raisins, but I don't know the pounds of walnuts that go with that. So let's do that work on the other side. So this time I know Remember our equation is 4x plus 8y equals 15. This time I know the pounds of raisins is 1.75, but I don't know the walnut, so I'm going to leave that variable for the walnuts, y there, and let's go ahead and solve for the walnuts this time. All right, so 4 times 1.75, 4 times 1.75, my calculator might still be updating, but I've got that, so 4 times 1.75 is 7. So 7 plus 8y is equal to 15. All right, so let's go ahead and solve that for y. Get y by itself. So we'll undo that positive 7 by subtracting 7 from both sides. That leaves me with 8y is equal to 15 minus 7 is 8. Both of these turned out to be kind of nice. So undo multiplying by dividing both sides by 8, and I get y is equal to 8 divided by 8, which is 1. So that is another combination that works, 1.75 and 1. So 1.75 and 1, so that's going to be that point right there, about 1.75 matches up with 1. So that's the point, 1.75 and 1. All right, so there are so many combinations of raisins and walnuts that would work. Anything between that y-intercept up here and the x-intercept over here, anything along the line between those two would work as a combination. And we have, 6 of the combinations right here on our table that could work.